Hello guys, this is just an overview of what we'll be able to build by the end of this first part of this tutorial. There we are trying to build our own Claude Code using LangChain and MCP servers. So in the end, by the end, we'll be creating an orchestrator agent, which will be our master agent and create multiple sub-agents like executor agent, planner agent, reflection agent, and workspace agent. And we'll be using MCP servers to work with files, and like GitHub and Git and cells commands. Okay. So our orchestrator agent will be main agent. Then we'll have a sub agent, planner agent. So suppose if you ask your AI to build a complete fast API CRUD application, here is an out. So it will try to like create a main.py file, readme file, requirement.txt file, whatever you give in the prompt, it will just create an end-to-end project for you. So this will be this is the like version of what you will be building by the end of this tutorial. So a planner agent which will plan what you want to build step by step, an executor agent which will actually execute the plan that we have created, a workspace agent which actually works with files, cell and other commands, and a reflection agent which will basically work. Suppose if you are getting an error in the code, then this will just read the error and retry to fix that. So this is what will be helped by the first part of this tutorial series. So let's get started.
Hello everyone, welcome back to my YouTube channel, and today we are going to build another multi-agent system, and here we will be building AI developer workspace assistant. So something like Claude Code or Codex. So basically we'll learn a lot of things. The main core thing that we are going to learn is multiple agents, how to build multiple agents and how to orchestrate them. One core feature that we'll also focus on is MCP tools. So far we built few LangChain projects like YouTube Summarizer, and in the previous one we built the research agent. Okay. Now we also built another resume interview agent, but those are some very simple agents. Let's move to build something complex. Maybe a swarm of agents where we'll be building multiple agents and we'll try to make them connect each other or like communicate to each other. So that's what we are trying to build in this project. Let's get started. So the concept is we will be building AI developer workspace assistant, an AI agent that can read files, search code bases, edit files, execute shell commands, inspect projects, debug errors, generate code, run test. We'll be also adding few more things like you will be able to create GitHub pull request. You will be able to find out all the issues that are there in your GitHub repo, all those kind of things. So we'll do it via MCP. So in the first part, we'll mainly focus on the MCPs, okay, which is Model Context Protocol. In the previous tutorials, we learned about chains and agents, and where there we learned that we can create tools for our agents. Those tools, agents can like invoke those tools and do some kind of computation. So MCP is more standard format to invoke those tools. We'll learn it in a moment. So if I just go down, what we will get in the end. So in the end, like if you type find all fast ticket routes in and generate documentation, then in your agent will search all the file, read all the routes, analyze all the code and generate documentation for you. So it will do all these things. Yeah. The core thing that will be focused is on MCP fundamentals, MCP servers, clients, tool schemas, tool calling, agent orchestration, multi-tool workflows, async execution, AI planning, and context management. So in this first tutorial, or the first part of this tutorial, we are mainly going to focus on MCP. Okay. So the main thing that I want you to understand is MCP fundamentals. Once you understand it, you will be able to build nearly anything that you want. You can just create an agent for that. So our goal is to understand MCP client, MCP servers, tools, tool schemas, and transport. These are 5 things that you should focus on in the first part of this video. So let's get started. For this, I have a documentation here. If you go to this huggingpage.com, learn MCP course and unit 1 introduction, I'll just leave this link in video description. Here you will get a detailed information what an MCP is. So I'll just give you a quick overview on this. So yeah, the AI system is evolving rapidly with LLMs and other blah blah blah, all these things that we just go to here. In the next key concepts and terminology, if I come. Okay, so see here. Currently, what we are building, we are building try to build an agent. The agent is connected to some kind of front end. The front end is handled by the user. User writes something on a front end, which is our instrument application in previous tutorials. Then that agent tries to find out if the user is trying to invoke any tool. If yes, then it invokes the tool, do some kind of computation and return the result. Okay. But now you might have seen that we were building many tools and you have to write tool for nearly each thing. Now the issue is you may write your tool in one way, another developer may write the tool in another way. Also, every user has to write their own tool. So there is no way we can share tools between multiple developers or multiple agents. So for that, Anthropic, which is also the creator of Claude and Claude Code, they come up with an idea of MCP, which is Model Context Protocol. So here we have an issue which they have mentioned, the integration problems. Let's say we have M agents and we have n number of tools. Then what if each agent has to connect with each tool? Then there will be a problem. There will be M into n connections, which is a quite an issue since we can't load every tool to or give each tool to every agent. Okay, so that's a problem. So how did they come with a solution? They created MCP servers or MCP protocol, which is Model Context Protocol. So here we have an agent. Okay, here it will be simply a model, and we have tools like database tools, file system tools, calculator tools. In between them, there is sits a MCP. Now, if an agent wants to use this, it will only tell that this MCP that I want to use the database tool. So what will happen? The MCP is mainly made of two things: MCP client and MCP server. So MCP server has the access to all the tools, and MCP client decide which tool to use. So if I just come down, so we have a distance MCP client, MCP server, and a tool. So MCP client, you can think it like this. Like this is my VS Code. Okay. So you can call VS Code as MCP host. Now inside this, you will see this toggle chat. Now you can call it a client because here I can write that I want to use a particular tool, and this is an agentic system and it will just invoke this. So you can call this client, this entire VS Code as host. Then server, we have to create our server, or you can use a third party MCP server. For example, you can use a GitHub MCP. So you can just search GitHub MCP and you will find a server which is hosted by GitHub. So we can either run the server MCP server on a system or we can host it. So we'll learn it, don't worry. Now the next thing is, if I just come to this key concept in terminology. So here they have mentioned three things: host, client, and server. So again, host is your main application. Client is a part of your host which actually does connection with the server. And server is an external tool which basically gives you the tools, resources, and prompts. One more thing that I want to tell you that so far in the previous agentic tutorials, we only learned about tools. We learned how to use a calculator tool, how to do the web search tool, how to use the weather tool maybe. But MCP allows you to access more things like resources and prompts. So instead of tools, you can also read resources. Resources means, let's say you want to fetch the documentation. That is not a tool because we are not computing anything, but we are trying to just read content from somewhere. So you can load resources. You can also load prompts. Maybe like you can say that this is my prompt and this is how I write pull request. So you want your AI agent to write the pull request in the same form. So in that case, you can set a prompt it to on the MCP server and it will be able to fetch that. Again, there are a few things that MCP server provides us, like tools. You already know it. Resources. These are read-only data sources that you can read, like for some scientific papers or some kind of documentation. Then prompts. This can be any prompt, a summarization prompt, a PR prompt, a issue prompt, whatever you want. This is last thing is sampling. We'll learn in some other video because this is more advanced stuff. Now, what is the architecture? There is an LLM, which is basically your agent. The agent tells the MCP client that I want to use some kind of tool or some kind of resource and some kind of prompt. And the server will send that tool or resource or prompt to the agent. Okay. So this is it. Now, if I just go to the next page, they have just explained this in detail. You can read it if you want. Now, a host can have multiple MCP clients. Okay. And each client will only collect to a one server. Okay. So keep this in mind. A host can have multiple clients. So VS Code can have multiple MCP clients, but each client will only connect to one server. So here, let's say it may be connected to GitHub server. It may be connected to Slack server, MCP server. Okay. So it's something like this. So host is the user facing AI application. For example, take the example of Google Chrome. So this Google Chrome will be your host. Now, if you type www.example.com or whatever website URL, now there is a network handler, right? Or what we call V8 engine, which is actually your client, which does this request to the server. So you can think it like this. So there is a host, then we have the client. Client is a part of host that manages communication with MCP servers. So each client maintains one-to-one connection with a single server, handles protocol level details, and acts as intermediary, host logic, and external server. Now the server is something just like HTTP server. Okay. So you can create a server and anyone can use it. For example, in the previous tutorials, we were creating tools and that tool was specific to LangChain. Only LangChain was able to use that tool. But now if you create an MCP server, you can just use it with anything, any LLM, any tool. Just like take an example of HTTP APIs. So what we do once we create the APIs, we can anyone can call the API. Maybe you can just type the GET request on your Google Chrome browser. It will return you the response. If you just do a curl command on your this system, you will get the response. You can open that same in Postman and you will get the response. So see, you design the API once and you can use it anywhere. Similarly, you can design the MCP server once and you can use it with anything. Maybe Claude Code, Codex, or whatever there is. You can use it with anything. Now, is there something important? One more thing that I wanted to show you, the communication protocol. So the communication that is protocol that is used by MCP servers is known as JSON RPC 2.0. Basically, just a JSON file which is shared between client and the server. Okay, so it is in this format. You'll get a JSON object like this. Here it will be mentioned the version JSON RPC. Then you will get a unique identifier. Then what the client is wants to do. So here is the method. So basically, the client wants to access tools or call the tools. Then you have to send the parameters. So you have to pass the name of the tool. You have to pass the argument. So this is one example. Similarly, in the response also you will get the similar JSON response. So JSON RPC version by unique identifier. This identifier will be same as this identifier. Okay. Now you will get the result like this. Similarly, you will get the error if there is an error. So I think one last thing that is left is this transport. Okay. So basically you can get two types of there are two types of transport mechanism. So JSON RPC defines the message format in two formats. STDIU, the standard transport is for local communication where the client and server are on the run on the same machine. So in this tutorial we'll be working with STDU or standard input arm. Basically, I will create my MCP server on my system and my client, which will be a LangChain agent, it will also be on my same system. So they have to communicate. So how they can communicate? They can communicate by a standard input out. The second thing is HTTP SSE. Suppose your MCP server is deployed somewhere else on a remote machine. For example, GitHub MCP. This is deployed on the GitHub machine. Okay. So if I want to connect, so for that I have to use HTTP or SSE transport. So there are two transports: STDIO for local MCP servers, HTTP SSE if it is required somewhere else. So I think this is it. Now let's move to the coding part. For this, you have to install few things. I'll be using fast MCP to build the MCP servers. The first phase of the first part of this video will focus on MCP servers. So let's do it. What I will do, first of all, I'll create a virtual environment. So when I can then I will simply activate it. So when slash bin slash activate. Perfect. Now all that I have to do is install the requirements. So install -r requirement.txt. It will install all these things. I'll be using Gemini. You can again use whatever LLM you want. Maybe OpenAI or Claude, whatever. It's up to you. You can use open source models. So once it's installed, again we are first going to focus on MCP servers. Then we will create our agent. Then we will make sure that the agent is able to connect with the MCP server. So this is the first part of this video. Perfect. Now let's get started. So once the requirements are installed, we can actually try to code it. So let's get started. First of all, we'll try to build a very simple MCP server. For that, I have to create a folder server. Inside this, I'll create a file system server. So this MCP server will help me to interact with my file system. I'll be able to see what files I have. I will be able to
search for files, create files, read files, write files, all these things. Okay. For that, what I'm to do, I'm to import from fast MCP, import fast MCP. Okay. Now I can create MCP server like this. MCP equals fast MCP. I have to give a name to my MCP server. So I'll give it as file system server. You can give it any name, but make sure it's meaningful because your AI agent will use this name. Okay. Then now if you have to create a tool, you can just create it like this mcp.to. After that, you have to create a function. So I'll create this list files. This is my very first function and first tool which will help me to scan a given directory. Now it will take a path which the folder I want to see, and it will return a list of string, which means it will return a list of file names from this folder which are there inside this folder. Now I'm getting a list error, so here I can import from typing import list. Okay. Now inside this you have to write the documentation or doc string of your tool. Now this is very important because agents read these documents, then only they will know what this function actually does. So I'll write returns the list of all the files in the given folder. Now I will tell that it takes a parameter known as path, which is of type string. So here I can write path of the folder to be scanned. Then I will write return, and here I will write returns the list of files in the given folder. Perfect. Now we have to write some logic via which we can get the folder, sorry, the list of files inside a folder. So for that, I'm going to use another library from pathdep to import path, and I'm going to create a function. So I can create a function here, def get full path. So if I give any path, I want to get the full path of that folder. Okay, suppose I want to see what files I have in my AI developer assistant. Then in that case, I want to get the full path. Then only I'll be able to scan it. So for that, I'll be creating function and I will return path, and it will take the path which is given by the user. And here we have write expand user. And what does this mean? Suppose you have this given this tilde sign, what it will do, it will just expand this entire in like users and then usernames kind of like that. Oh, dot resolve. So this will give me the full path of the folder. Okay, perfect. Now I will set a variable target and I will try to get the full path of my path which the user has given. Now if I will check, if not target dot exists, then what I can do, I can return an error. So return, you can say maybe folder doesn't exist. Now this is not a very good way to return the error. We'll learn it, but not right. For now, this will work. Otherwise, what I can do, file name or file in target dot iter dir. Basically, what I'm going to do, I'm just going to iterate on all the files of this target folder, and then I'm just going to return a list comprehension with list name of all the files in this folder. Okay, so our tool is ready. Now we can try to check it. So if name is equal to main, then in that case, I want to run my MCP. So all that you have to do is type mcp.run. Now you have to keep one thing in mind, that we have imported two libraries, fast MCP and MCP. Both are used to create MCPs. So if you switch between them, you might get some error. Let's see if it works or not. So what you have to do, you have to type fast MCP and then dev. We can do this thing, fast MCP, let's just help. Okay, so there is a bunch of commands that we can check. So fast MCP is the fast Pythonic way to build MCP server and clients. So we are going to use this development tool for MCP servers. To do this, you have to run fast MCP dev and then path of your MCP server. So my folder path is server/file system underscore server dot file. So server/file system server dot file. If I enter, I'll get an error probably. So it says unknown command server/file system server. Available command says inspector. So basically you have to type inspector after dev. Inspector. Hit enter. Now it will open a port on your system. So 6276. I think I have to kill this port. If I try to connect, I will get an error probably. Okay, so I'm getting an error. Let me just do one thing. I will just kill this port and run this program again. Let me just run this once again and let's see if it works or not. So if I try to connect, okay, I'm getting error. What you can still do if you are getting this kind of error, you will get an URL here. So just copy this URL, paste in your browser, and you can now try to connect and it will work. So once you get a connection, you will get a server notification/message. Okay, now what does this mean? See, first the MCP was initialized. You would see this. Then you will it is setting some kind of logging, and your server will always send a notification to the client that yes, it is connected. So now what you can try to do, you can see you have multiple options here like resources from tools. Now if you remember, we mentioned about multiple things that we can return from MCP. So one is resource, then we have prompt, then we have tools, we have other things as well. So first of all, you can just ping server to check if it is working or not. So yes, it's working. We are getting a ping. Okay. Now you can just go to tools. Since we have not configured resource or prompts, we have only configured tools. You can just click on list tools and you will see a tool here, which is list tools. So if you see, your MCP or fast MCP will automatically create an schema for this. Okay. So it knows what does it takes. So return the list of all the files in the bin folder. This is the argument and this is the return. Now what I can do, I can try to give any folder, maybe this folder, and let's see if it gives me the list of all the files in this folder or not. So let's just run this tool and let's see if it working. So we got a 2-digit success with structured content server to-do.md when my requirement text. Now if I go to here, you will see we are getting the list of files which are there inside this folder. Perfect. So our first tool is working. Now we have to work on our second tool, which will be to read the file. So how can we do it? We can just create another function or another tool for this, which will be read file. So we can just call it like this mcp.tool, and we can create a function def read file. Again, it is going to take a path which is of str. This is the file path, and it is going to return the content which is again with a string. So I can just say read the content of the given file. It takes an argument whose name is path, type of string, and basically it is the takes the path of the file to be read, and in return I can say that returns the content of the file. Perfect. Now what I can do, I can just get the full path. So target is equal to get full path, and what I can do, I can just return target dot read text. Perfect. So now if I just go to my MCP server, okay, so I have this file path, keep in mind, and I have a file maybe as 22.md. I will try to read 22.md. So let me just clear it, and I'm again going to click on list tools. So now I have two tools, read file and list file. So I'm going to for read files. Here it takes the path, and after that I have file 22.md. So if I hit enter or run this tool, I should be able to get the content of this file. So if you see, I am getting the content of this file. Perfect. So this tool is working as well. Now there is a possibility that
the file that you have given does not exist. So in that case, we have to raise an error. So how to properly raise errors? You can import a library for that. So first MCP dot exceptions import tool error. So basically, if we don't get the path, we can return tool error. So instead of returning, which is a bad way, we can raise a tool error. So tool error, and here we can write path does not exist. Okay, something like that. Instead of path, we can also print target. Perfect. So if the path doesn't exist, you can just say the path doesn't exist, something like that. So we will just copy this and paste here as well. Perfect. Now let's create another tool, mcp.tool, which will be to write a file. So def write file. Now it is going to take two things, the path of the file where we want to write and the content that we want to write. So both of this will be a string, and this will return a boolean value, either true or false. So I have to write the doc string. So we can write the given content to a file and saves it. Now we can pass the arg, which is it is going to take path which is of type string, and here I can write the path of the file and the content, which is obvious string, and here I can write the content to be written in the file. Perfect. In return, now you might wonder why we are writing this, because our agents will need this to understand how the tool works. So that's why make sure your log strings are detailed. Returns true if file is saved, else false. Perfect. Now we have to write the file. So we can just copy this thing or target. Now we are not going to raise an error if the file doesn't exist, because if the file doesn't exist, we will create a new file. So you have to write target dot parent dot mkdir. So since this is a path, we have to create a folder first. Okay. And then we have to write a file inside that. Which is true. So basically this will create a folder first if the folder doesn't exist, and it will create a file inside it. So target dot write text, and inside this we have to pass the content. Finally return. Again, you can use try and except to do this, and return false if it fails. So let's do this, and let's just build one more tool, which will be to search the files. So mcp.tool, and I'm going to create search file tool, which is going to take path of a folder where I want to do the search and the name of the file I want to do the search for. Okay. So what it is going to do, it is going to return a list of file names or list of str. Now I have to write this doc string. So recursively searches for files matching the given file name or blob pattern under the given folder directory what we want. Now we have to type arg. So arg is a path. This is of type str. So the directory to search in, and then the name, you can also call it file name if you want, whatever. So we can say exact file name or a blob pattern. So suppose I want to search for a file which starts from file system. So it will work like that. Or suppose if I want to list all the files with inspeed.py, so it will work in that case as well. Okay, because we are using log patterns. Then for return, I can simply say list of absolute paths of all
matching files empty list if nothing matched. Perfect. So this is docstring. Now all that I have to do is write the function code. So I can just copy this thing, paste it here, and we can return str match or match in target.rlog, and you have to pass name. So basically, this will do a pattern matching. If the file exists, it will return the full path of the files. If it doesn't exist, we will get the empty list. Perfect. Now let's just clear this, refresh our tools, and we should be getting 4 tools now. So this tools, there is some issue. So let's see. Let's restart it. So actually, we are getting an error. It should be list. Perfect. So if I just now restart the server, let me close this as well, and let me open it via URL. So if I open this URL, oops, um, okay, so let's connect to our MCP server. And here you will notice that the transport type is studio because our server is running locally. Command is past MCP. This is the argument. You can set more things here, but for now, let's just list all the tools. So now I have 4 tools: read file, list file, write file, search file. So let's try write file. For that, I'll just go to my folder. It's here. So I'll just give this path, and I'll say with me hello.md, and I will pass the content as hello world. Perfect. Now if I just run this tool, I'm getting a success. So results true, it means the file was created. So here you will see hello.md was created. Perfect. Now you can create a delete function as well, whatever you want. You can now do anything. Okay. Finally, we can go for search tool. So let's just give the folder path, and let's try to find any file starting with file system or maybe star.file. Let's check if we are getting all the any files which ends with .py. Or is our MCP crashing? So we have got a success. Okay, so basically it just went inside the when folder. So that's why we are getting a lot of output. Okay, overall it works. So here it entered inside when. Okay, so we have to restrict it. So we can add multiple things. Now I hope you have a basic idea of how the MCP works. We have created a MCP server. Now we have to create an agent which actually interacts with the MCP server. So this is server. There are 2 ways to run it, either via STDIO, since which we are doing, or another ways is via HTTP. So you have to run it as a HTTP server, like we do for HTTP servers. We have to do the simple as perfect. So for this, we created the server. Now we have to create a client. Okay. So your client can be your Claude Code as well, but here we are going to create a LangChain flag. So for that, what I'm going to do, I'm just going to create a folder. So here I'll create a folder as agent, and inside this I will create my first client, which is workspace agent. This agent will let me work with my folders, local folders. Okay. So for this, I'm going to use import ways, import async IO, and then from pathlib import path. Then I'm going to import from .tnb import load.tnb. Then I'm going to use LangChain adapters. So basically now you created a MCP server. Now you have to create an adapter. Now there are 2 ways. You can create a custom adapter
What is adapter? Basically, that adapter is a function which will tell that how to connect to the MCP, how to list all the files, how to disconnect all these things. We don't have to do it because we already have a MCP adapter. So we can just search here LangChain MCP adapter. So you can install it like this. You can install LangChain MCP adapter. So let's just install it. Perfect. Now, since we have installed, we can just import it. So from LangChain MCP adapters dot client import multi server MCP client. Perfect. Now I'm using from LangChain Google Gen AI import chat generative chat Google generative AI. This is how we are going to use our LLM. And I'm going to write from LangChain dot agents import create agent. This function will help us to create the agent. Now we have to check how can we install this. So you can just search. You can install it like this. Quick install LangChain Google Gen AI. So just go here in your terminal and type pip install LangChain Google Gen AI. It will be installed. Perfect. Now we have this code. Now first I'm going to use the going to load the .env. Then I need to pass the path of my server, MCP server. Now see, when we save stdio, basically what will happen, this is a file. When you will ask your agent to use this tool, what it will do, it will just create a sub process, and that sub process will read this file, run this tool. That's all it will do. So I'm going to create a variable server path, which basically means where my MCP server is stored. So for that, I'm going to create a function path which will take the file path of the current file dot resolve dot parent. Then add a server folder. Then add a file system server dot py. Now what does this mean? str path of file means the current file, which is this workspace agent. When you do resolve parent, so basically you will reach to the root of this project inside this folder, main folder. Inside this we have a server folder which is written here. Inside that we have a file system server, it's written. Perfect. Now we have to create the agent. So async def get workspace agent. I'm going to create a client. So client equals multi-server MCP client, and we have to pass the details. So as we mentioned, as we learned that MCP servers use JSON RPC 2.2. So there we have to pass JSON. So if you want to use the MCP, you have to tell the MCP name. In my case, it is file system. Okay, and then you have to tell how to invoke this MCP. So you have to write a command, which is Python in my case. Now this is when we run our MCP server locally. Then you have to tell the arguments needed to run this. So it will be equal to server path. And then we have to tell what kind of transport we are using. So which is STDI. STDI. Perfect. So now we have created the clients. Now let's just read all the tools. So await client dot get tools. Now if you see, this is a little different from the previous one. We did use the create agent, but this time we are using MCP. So this MCP has wrapped all the tools. So we are not creating a list here. Okay? Now we have to create a LLM. You can create a single LM, you can use multiple LMs, whatever you want. So I'm going to give a separate LLM to each agent. So model equals Gemini 3.1 to preview. And then we have to set the Google API key. So Google API key, which will be equal to os.getEnv, and we have to set Gemini API key. Now for this, what you have to do, you have to create a file here and .env file, and you have to set this variable value. You need a Gemini API key to run this. Okay, perfect. Now that we have created the agent, what I can do, I can simply return the create agent. So return create agent, and here we have to pass the model. So model equal to LLM. Then we have to pass the tools, and here we have to pass a system prompt, which will be equal to you are a helpful workspace assistant that can list, read, write, and search files. Perfect. So our agent is created. Now whenever you call this function, we will get an agent created. Now let's try running this. Let's just test this agent. So for this, I'm going to create another function, async def main. So inside this, I will create a function agent equals await get workspace agent. Now this will create a agent for me. Then I can simply call agent dot invoke, and it inside this I have to pass the message that can you list all the files inside. We have to pass the path. So let's maybe this path. Okay. Message is equal to agent.invoke. Let's just try to print message and let's see if it works or not. Finally, you have to run print asyncio.run, and you have to pass the main function inside this. Now what we can do, we can just run python agent slash workspace agent. So if it works, it works. Otherwise, we will get an error. So now module name LangChain. Not an issue. We have to install LangChain. So we have to install LangChain. Hit enter. So it's installed now. Let's try to run it once again. Str object has no attribute resolve. So we are getting an issue in path. Basically, we have to remove this thing and pass it here. Perfect. Let's try to run it once again. Async IO. Again an error. This time another error. So async IO, a coroutine was expected, got function main. So I say a coroutine was expected, got function. So actually I just pass main. I have to pass it like this. Secondly, I have to it doesn't take a list like this. We have to take in a specific format like this. So agent equals await get workspace agent. Response equal to agent dot a invoke. So this time we are not using invoke. Previously I was using invoke, that was sync. But our function is async. So in that case, I have to use a invoke. Okay. Now I have to pass a message list. Inside this, we have to pass the rule as usual, then a content. Perfect. Now let's try to run it and let's see if it works or not. So you can see first MCP was started. We are getting a logo for this. We are getting some more info. So here we are getting a list of all the files inside is a function call was made, and list all files inside this web message. And additionally, when I call, we are not getting the output, right? No, actually we are getting in that. So here you can see we are getting an output. For result, env server to do when agent requirement.txt. So here are the files and directories inside this. So you are seeing we are getting an agent. So we have created a client. So this is our agentic client. Okay, we have created LangChain agent, which is our client. Then we have created a MCP server. So whenever the agent need to activate this server, we have to just tell that I want to use this thing. Now the agent will automatically do the reasoning and call the proper MCP. So this is another part where we learn to create the client. Now this is one client, one MCP. Okay, but what we want to do, we have to create multiple clients, multiple MCPs, and there's the orchestrator. Then we also have to create the UI. So that we'll learn in the next part. Hello guys, welcome back. So by now you must have a very basic idea of what is a MCP and how we can connect our agent via that MCP. Moving further in this part of this tutorial, we'll try to create more MCP servers. So we already have a file system server where we are able to like list files, read files, write and search files. We'll add more functions in this part of this video where like we can do search code in a file. For example, I want to search a very specific code, maybe get workspace agent definition. So I can search it via like recursive searching. Okay. So we'll add files for this. We'll also create also add functions to delete files, maybe all of those kind of things. So we'll do it in a moment. But before that, let's create another server, which is cell server. Okay. So now our architecture will be like this. We'll mainly create three types of server in this part, which is one is file system server, second is cell server, third will be Git server. Now all three will be connected to this our workspace agent. Okay. So our workspace agent will be connected to three MCP servers, my file system, cell, and Git. So let's code cell server first. Now it is very important. So what you have to do is just copy this thing, paste it here. Now we have to create the MCP. So we can create MCP like this. We already know about this. We can give it a name. So I will give it cell server. Then I'll give a list of allowed commands. So basically what this server will actually do. So suppose if you want to run any command on your terminal, so this server will help us to run commands. So what I want is I want to allow a list of commands. So let me just copy paste. So I'll just copy paste a list of allowed commands, block commands, and unsafe shell characters. So basically, if I want to, let's say I want to find out which directory I'm in, so I can directly run tw. So our agent can run this via this particular MCP sub. So here is a list of commands that I want that agent should be able to execute, but the agent should not be able to execute these commands. These are blocked. For example, I don't want my agent to shut down my system. Okay, and then there are some unsafe shell characters that I don't want my agent to do. Okay, or run. Perfect. Now I'm just going to create a function. Now here I'm creating async functions. For file system, we were creating sync function, but you can try to convert it into async as well. Though we do not have any async code here. Okay. So now what does async means? I don't want my agent or my event loop to get blocked because some of this command, for example, recursively searching text in a file. Now there's a possibility that there are a lot of files and you keep searching text in those files. So it will take some time. And I don't want my agent to be blocked till that time. So for that, what we are going to do, we are just going to create async functions now. So run cell command. Now this is our key function which will be executed to whenever we want to run any command. So it will take a command and it will return a dictionary. Now how can you run this command? So basically the idea is I have a terminal, if you see here, and if I type pwd here, I'll get some output. So this was my input, which is your command, and this is my output. Okay. So this thing that is getting printed on this terminal is known as standard output. Similarly, let's say if I type something wrong, PWC, now I'll get an error. Okay, so usually this is not error, some kind of info, but this is known as standard error, something like this. So there are two things: standard output, standard error. So standard output when your command succeeds, standard error when your command fails. So that's we have to do the same thing. We have to run the command whatever the user is giving in a terminal and return either the success or error. So first, what I'm going to do is first I'm going to check if the command is allowed or not. So what the command looks like, for example, suppose I want to run a file. Maybe let's say I want to run Python cell server. So this is my command. Now see, first I want to check if this is the first part of command is allowed or not. So what I'll do, I'll split the entire command and check if the first word is in the allowed commands or not. So for that, what you have to do, you have to split it, command dot split. Perfect. Now, if you can do something like this, if not parts return success is equal to false, error unsafe cell character detected. Basically, there is a possibility that the user is just typing enter and asking the agent to run it. So that's a issue for that. So that's just a check for this. Now we are just going to take the zeroth element of this list. Now when we do the split, the command will be splitted into a list. Okay, and I want to check the first part, which is Python in APIs. So if I'm just going to check if any token in command or token in unsafe cell characters, then again I'm going to base an app. Basically, what we are doing here, we are checking if our command contains any of these characters. In that case, I don't want to run it. Okay, so I'll just return an error. Perfect. Now I have to check if base command, actually it should be base command. Okay, if this command in block commands, if this base command is here, like if the user is given RM or shutdown, anything like that, that in that case also I want to return an error. Okay, I will simply say permission denied for this. Now, also if I want to check another thing, if base command is not in allowed commands, I want to return another error. So you see, we are just checking so far that I don't want my user to execute anything. Otherwise, possibility that I'll delete something important or some mishappen may be possible. So that's why we are just adding multiple checks so that the user cannot run any unsafe command. That's it. Perfect. Now, since we have all the checks done, what we have to do is we have to run this command that user has passed into our terminal. Now, for that, we have to run it in a sub process. To do this, you have to do it like this. First of all, keep in mind that we are using async. Okay, we are creating a async function, so you can both sync IO. Now, I want that my function should be executed in a terminal in a background to async manner. So, what you have to do to type await async IO dot create sub process cell. So basically, it will just think it like this. It will initialize a terminal for you, which will take command and it will take a standard output. I showed you what was the standard output. So async IO dot subprocess dot pipe, and similarly you have to pass the standard error. And it is also the same async IO dot subprocess dot pipe. Okay, perfect. Now it will return us either the output or the error, standard error. Okay. So in that case, we have to do async IO dot wait for. So basically, I'm going to do, I'm just going to create a terminal. Okay, I'm going to pass the command to it. Now I'll wait till this command is executed. So for that, I am waiting here. Wait for. I have to pass the process dot communicate, and I'll have to tell how much time I want to wait. So I will give a timeout of 15 seconds. So I will wait 15 seconds for my command to be executed. Once it's done, I'm just going to return it. Okay, so return success. Here I like to check process dot return code is equal to 0. So if it's 0, then our command was executed successfully. Now this will return you something, which is okay. So if it returns, if you want, you can just learn more in detail about Linux subprocess. You can find a lot of tutorials on YouTube or maybe on ChatGPT. You can just search it. Then we have to just, it will also return you standard output. It will also return you standard error. So
You can call it like this: std error dot record. Finally, we'll have return code. So we can return process dot return. Here also it will be process, and here also it will be process. Perfect. Except we have a time of error. So async IO dot time of error. In that case, I will first kill my process. Since we have initialized the process, we have to kill it, and we will return an error. So return success is equal to false, and I'm going to return an error command time out. Now this is just a function. This is not a part of an MCP tool or submit. I can call this function if I want to run. So for now, since our core function is created, we can create tools around it. So I did mcp.tool. I'm going to create my first tool. Again, now our function is, since this function is async, I have to convert this function in async as well. So I'm just going to create my first command, first tool, which name is command. Now it takes a command and returns a dictionary. This dictionary is same as this dictionary. Okay? Whatever this function will return, this will return. So I'm just going to add a docstring to it. Okay, like this. And then I'm simply going to return await run cell command and return the command or pass the command. So basically, the user will give a command to the agent, and the agent will invoke this MCP tool, whose name is run command, and this command will then go to our this function, which takes this command and runs it in a sub process or a turn. Okay. Similarly, I create more tools. So mcp.tool, and I will create a function async def get working directory. Okay. Now this will not take any argument, but it will return a dictionary. Now to get the working directory, you have a command pwd. You can. So I'm just going to paste it docstring. Okay. And I'm going to return wait. Now we are just going to reuse the commands, reuse the main function that we have created, and we just have to pass pwd to it. Perfect. Now I'm just going to create another tool, which is to run a Python file, async them run Python file. Now it will take a path of the file which we want to run, and it will return a dictionary. Okay. Again, I'm just going to use the same. Okay. So I've added a docstring. Now we have to write the logic for this. Again, this is very simple. First of all, I have to go to this here. First, let's just copy this path function and paste it here. So we can paste this function here. Perfect. Now I'm just going to get the full path of the file. So you can get it like this: target equals get full path, and you have to pass a path here. Then I have to check if not target dot exists. I have to check if the path exists or not, or the file exists or not. If not, I'm simply going to return success false with the error message, which will be file does not exist. Okay. Also, I can check like if the file is not Python file. So for that, again, I have to read the error. So you can check it like this: if not target, or you can also say if target suffix is not equal to dot py. It means if the file is not ending in dot py. So then in that case, you can also raise an error. So only Python files are allowed. You can also read this tool error if you want. It's totally up to you. Otherwise, if it is a Python file, I have to create a command. Now, what is a command to run Python file? We already know.
You just have to write Python and then the file name. So we are doing the same pro. So Python, and you to pass the file name, which is targeting marks. Finally, we have to return a wait, run cell command, and you have to pass the command that we have created. Perfect. Now you can add more tools if you want, but for now, let's just wrap it up. So if name is equal to main, then in that case, what I want to do, I want to run the MCP. So MCP dot run, and you can tell the transport. Last time we didn't pass it. You can still ignore it. You can just type MCP dot run and it will work. But I'm just showing it that we can also pass parameters to it like this, and so banner is equal to false. Now, if you remember, when we ran the file system server, it was showing a fast MCP written on your terminal in large fonts. If you don't want that, you can simply pass so banner equal to false. Perfect. Now what we can do, we can try to run our cell server. So for that, we have to type fast MCP dev inspector and then this file path. So server slash cell server dot py. So I'm getting a URL. I'll paste it here. You can just copy this thing, close this one, and in this one instead. 627. Let me check. I think it will be 6275. Let me try to connect. If it works or not. No, it returns an error. Let me try once again. Okay, so it's connected. Perfect. Now we have not created any resource, no prompts. We have created tools. So we can search for list tools. So we have this tool. So run command, get working directory, run Python file. Let's try run command. So I can just simply pass a command to check if it works or not. I'll simply pass date command and check if returns the date or not. So I put an error calling it tool run command. Process object is new attribute decode. Actually, it should be here. The issue is here. We have to take the standard output from std output, and we have to take a standard error from std error. It's not in process, but in here. So what we can do, we can try to run it once again, and let's see if it works. Int object is not callable. So where I'm calling the int here, basically it is a integer, not a function. So let's try once again. Yes, see, I'm getting the output. So success is true. Standard output. This is the output when you run the command. There is no error, so standard error is empty. Return code is 0. Okay. So if a command runs execute successfully, then you will always get a 0. Otherwise, you will get some other number. Perfect. Get working directly. Let's try to run this. It doesn't take any argument. So let's check it. Perfect. It's working. Now let's also take the third command. So what I'll do, I'll create a file here. Test.pyth. Okay. And then I'll just add a command. So print, or maybe type for I in range 5, print test is working. So I have created a very simple file. Okay. Now suppose I want to run this. So I will try to run it where it is copy path here. Let's try to run it. So I want to test my third tool, which is run Python file. Here I have to give the file path. So this is my file path. I'll try to run it. Let's see if it works on. So I'm getting success. So see, standard output test is working. Perfect. Now we are able to create a MCP server, which is actually running commands, getting your working directory and able to run Python files. Perfect. Now we can just add it to our system. So I don't need this test file anymore. I'll delete it. Now, since we have a cell server ready, we can just add it to our workspace edit. So let's do it. Now for that, what you have to do? First of all, let's just do this thing.
Here, what I will do, uh, remove this thing, remove this thing. Here, I will create a variable file system server. Okay. And then I will do something like this: str server path, then add s, and then paste file system server. Perfect. Now I'll create cell server path. So cell server is equal to str server path, then forward slash, then I'll pass my file, which is cell server dot py. Perfect. So now we have the path for both the MCP clients, sorry, MCP servers. All we have to do is we have to add it to here. Okay. So, oops, here I'm just going to pass another MCP server whose name is cell. Now again, it is going to take few things. So you just have to copy this, paste it here. Then here instead of server path, here it will be file system server, and here it will be cell server. So cell server. Perfect. Now our agent is connected to MCP. Now if I want, I can uh, do this thing. Like, what should I do? I can maybe try to ask what directory I am in currently. Okay, so this is my command and I want to run it. So how to do it? You have to just run Python agent slash workspace agent.py. Hit enter. Now see, your agent is connected to two servers: the cell server with its transport stdio and the file system server with its transport stdio. I'm getting something. So you are currently in the following directory: home, plugins, pyGuru, AI developer assistant. So you can see I'm in this working directory. How did it know? Because it is now able to execute the tool. Okay, so it will also have written if it has used the tools somewhere. Here, see, we are getting the artifact structured content. Remember, this was a thing that we were returning. Perfect. So it is able to call this function or MCP function get working directly. Perfect. So it's working. Now we'll add more servers. One key important server that you should add is Git server. Okay, so we'll add another server now, Git server. Let's add it. So Git server what py. Again, you just have to copy all of this. Let's just copy this. Here its name will be Git server. Okay, for Git server. Now the next thing is uh, I'm just going to copy a function here. Def get full path. And now I am repeating it multiple times, but you can just put in a single file and then import it whenever you want. Okay. Now I'm just going to create more functions. So async def run git. So this will be my key function. So main function, remember our main function was only one thing, run cell command. Similarly, I want to create one main function which will actually run the command. Now it will take a arguments list, whatever I want to run. Then it will take a repository inside which we want to run. So repository str is equal to, by default, which repository should be there? This is the repository. This is not a repository, but by default it will work in this repository one. And it should return a dict of it. Now I just have to do few things. Like first of all, I have to check if the target or the repository actually exists. So I can check it like this. So if not target dot exists, so in that case, what I have to do, I have to raise the tool error maybe, or you can just do anything. Path does not exist. You can just return a normal error. Okay. The JSON dictionary error. Perfect. Now I have to create a command which is actually going to run. So if you want to run git commands, remember to run it like git -c, then your repository path, and then your arguments. So basically, if you want to run, let's say git status, okay, so the command will become like git -c, then your repository. So let's say your repository is this AI developer assistant, where it will become like AI developer assistant, and then the argument. So argument is status. Okay. So this will this thing means this. Perfect. Now all that I have to do is run this. So for this again, I'm just going to use this function try. So let's just use this function. Paste it here. Again, you have to run it in your terminal. So process will be same. Okay. Here instead of single, you have to pass it as a list. Remember. Okay. So basically we are unpacking it. So here we have passed standard output. Standard is same. This will be same. Returns if it works then same. Us otherwise it will return an error. Okay. So time of error. Perfect. So this is the command. Now all that we have to do is create tools for this. So let's create our first tool, which is mcp.tool and sync def get status. One more thing, this function was like uh, recreated. Here it is all exists. What you can do, you can just convert your command and run this command directly. Okay. So you can do one more thing. Let's do it that way better. So from server dot get server import run shell command. Let me just check it if this is fine. Run shell perfect. Or no, let's just leave it. For now it was. Actually, we have to expand it. That's why I'm not trying to do it. But anyways, this is the same function. Okay, not in this one. Now here it will take a repository. So I have to pass the repository. By default, I'll just say that my current folder where I am in is my current default repository. It will return a dict. Now I have to type the doc. So let's write the doc string. Perfect. Now all that we have to do is we have to call the function that we created. So return await, and I have to run git command or call this function, and here I have to pass my command. So my arguments are log f. Oops, sorry. We are doing the get status. So you have to just write status and then the format. So post link. Basically, this is for just a better visible UI. That's it. Now we can create as many tools as you want. For example, at mcp.tool or sync def and get log. So it is going to 10 number of lines you want as log. So I am going to give it a default value of 10. Then repo. By default, my current directory will be my repo. Then dictionary. Perfect. Then we have to write the function. So in this copy pasting it, you can just type it. So the command will become run git. Then what was it? Git -c, then your repository path, then it will become log and hyphen in this format. This is basically formatting to present the data in a more better format. Then you can create more tools. So mcp.tool, sync def get def. If you want to get the difference or what the files that were changed, if you want to find that out, you can create the get def function. Again, we have to test the repository and it will return a dictionary.
So changes in working tree or index, it is going to check so stage changes or not, then the repository, or what it will return, dictionary with standard input, output and return code. This is it. You can create more tools if you want. Use a p.tool, maybe like get branch list, def get branch list, and then repository str a default repository, include return and dictionary. So it will list all the branches of your repository. Similarly, we'll have more commands like there are a lot of bit commands that you can like git add, git show, git blame. So what you can do, you can just go to this repository, okay, that I have created. You will get the code for AI developer assistant. You have to go to server, then you have to go to git server. And all that you have to do is you have to copy paste all this code tools. I can't just write like each one by one since it takes a lot of time and we don't have that much time. Okay. So just added this. In the last, you have to run if name equals mean mcp.run transfer distribute so benefits. Now what you can do, you can just try to run it as well as an individual tool like MCP. All that you have to do is let's close this MCP. You can run multiple MCPs as well. You just have to run it as separate terminal. That's it. Okay, so this time I have to run git serve. Hit enter. So let me just check where it is actually running on this URL. Let's check if it's connected or not. Okay, so it's connected. Again, you have to go to tools. You can just list the tools. And okay, I'm connected to some other. Okay, the previous one, not the current. So now if I just rerun it, I'll get more tools here. So get status, get tip, get current, branch, all those kind of things. Okay, so what I can do, I can just take a repository, which is actual repository. This is not a repository. So if I just go to cd dot dot, I do ls cd dot dot ls cd maybe me flow or sorry, maybe I should go to LangChain slash chatbot. Okay, so this is a repository actually. I can try to check uh, git branch list on this repository. So I have to just pass the repo path. If it works or not, let's check. I am an error. Path does not exist. So it says this path does not exist. Why doesn't it exist? Okay, so I think there was a space. You can add a strip. Okay. Error calling to get branch list. Create suppose a cell, multiple values for argument standard output. So it is because if I go here, uh, instead of cell, if I use exec, then I should end getting this prescribe also. Okay, so now we are getting out. So we have these branches main, which is actually remote's origin main. Perfect. So now I can, if you want, you can do run anything, but this is how it works. Okay. So we are able to run git commands here. Now all that we have to do is we have to add it to our workspace system. So for that, what I'm going to do, I'm just going here and we have to create another git server path. So for that, I'm going to create git server and here I'm just going to pass str server path, then followed by our git server.py. Perfect. Now all that we have to do is we have to write it here. So let me just copy this, paste it here, and here you have to type git, and rest of this will be same.
Okay. So our AI agent is now connected to Git server or Git MCP server. Now what I can do is I can check or run my agent with some code. So like on what was the last commit in our this repository, which is this one. Let's check if it works or not. So now all that I have to do is I have to run workspace agent.py. So see, now our agent is connected with Git server as well. And if it works, we should be able to get the output. So the tool was called repository is this chatbot, and the tool call was git log, and we have some output as well. Message content type text is this. Uh, the last commit in the repository is this is the commit has added more MCP servers extras. Perfect. So it is working as well. Okay. So now our agent can run git commands. It can execute commands on a terminal, or it can also create folders, read files, all those things. Now I can add more functions in file system server. So for that, what I need to do is I'm just going to this project. Okay. Server, file system server. So we had created till write file, search file tool. Here we have more tools. You can just copy it, delete file, and then create directory, file info, and then grep. So that's it. Let's just copy this, go to file system server and paste it here. Okay. So yes, this one is interesting. Grep. Using this, you will be able to search text in any file. If you want to search for any function, you can just invoke this grep function. So let's check if I can like get the content of any function maybe. So let's say I want to get the content of get current branch, and let's see if it works on. So if I just go to workspace agent, can you give me the definition of function get current branch? Yeah. So me it's O. So basically what I want is the AI to search for this particular function and show me the code. Let's see if it works on. So I'll just try to run it once again. So it is using file system server. Okay, so here it is. See the output. The get current branch function is defined to fetch the name of the active branch of the given Git repository. It wraps the execution of command git current git branch so correct. Here is the exact source for defining the function in the workspace. Found it this file. So this file was searched and we got this two. So this is the function code. Remember, this is the thing that we have written. Get current branch. So yes, our agent is now able to read files, search for particular functions. So you see now we are getting quite similar to Claude Code. We can search for a very particular file and we can search for exact code in that file. We can also update it. So now all that we have to do is we have to create more agents which can actually plan and write code for you. So this I hope this is the very basic concept of MCPs you are able to understand. You can create as many MCPs as you want. You can add as many tools as you want. It's totally up to you. Now we have a very basic base created for our AI developer assistant where we can do like work with file system, we can work with Git, and we can actually run commands or run the files. So I hope this is you learned something here. Don't worry, we are still left with like adding more agents. So that's we'll learn in the next part. Hi guys, welcome back to the tutorial. So in the previous part, we created a workspace agent which was able to work with the files. Okay, so we learned that give it an instruction like, can you give me the definition of function, did current branch, and so me its code. So basically, it searched for this particular function inside this entire directory and gave me its code. So it was working perfectly fine. Now let's move ahead and we'll move toward building our AI developer assistant. So now we have a very basic agent Tracy which can do anything with our files. It can create file, it can delete file, it can write code to a file, it can create folders, all those things. Now the next thing that we have to do is we have to create a agent for planning the thing that you want. Suppose by the end of this tutorial, what is our objective? Or by the end of this tutorial, I want you that we should be able to create a snake cube. Okay, in this part only. So we'll be able to create a snake game just by saying that I want to create a snake game, and our agent should be able to create the entire snake game along with creating directories, requirement, txt, everything like. Okay, so let's get started. For that, what I'm going to do is I'm going to create a planner agent. Now the task of my planner agent will be to create the plan for the project that the user wants to do. For example, I will say that I want to create a snake game. Now, a snake game is made in bunch of steps. Like for example, first of all, I want to create a folder. Okay. Then I might want to create a string.py file. Then I want to write some code in it. Then I want to create a requirement txt file. Then I want to maybe create a readme. And then I will say that the game is complete. So we have to do it in steps. Our planning agent will do the same. For this, I need to create a equal techniques. We need to OS import async.io. Again, we are using async.io because I don't want to block my event too. Okay. Then I'm going to use from typing import list and dictionary. Then I need to import from python tick import psmod. Then from dot env import n. Okay. Then I'm going to from LangChain to dot prompts import chat prompt chat prompt template. Then from LangChain to dot up parsers input identic out parser. Okay. Then I want to import from LangChain Google Gen AI input chat Google generative AI. This is your LLM, okay, which will actually do the top planners for us. Now we have a agent, we have a server here which we created in the last. So we had file system server, that server, cell server, like this, and we had the workspace agent. One thing that we can do is here actually is we can just copy this thing, okay, and I can just paste it outside it. So I will call it MCP config. So MCP config equals this thing. I'll just paste it. Perfect. Now I'll pass MCP config directly inside. Why we did this? Because we have to import this thing in a planner agent. So what I need to do is, first of all, do fetch from server. Remember, we have three servers, file system server. So I'll call it like from server, import file system server, cell server, and then get server. Basically, the idea is I have to pass the tools that whatever tools we have created in these three servers, we have to pass it to our agent so that the agent knows that we have these tools available with us and we have to create our entire project using these tools only. Okay. Then what I'm going to do is I'm going to create a prompt. So for this, you have to go to agentic AI project. This report link is in description. Go to AI developer assistant. You have to go to prompts folder and you have to copy planner agent. Okay, so basically the instruction for a planner agent, you can just copy it. You can write your own instructions as in matters. So let's create a folder. So I'll create a folder here and I'll create a new file inside it. Planner agent.py.
and paste it here. Okay. Then I will also create a new file prompt reader.py. So basically it will help me to read prompt. Okay. So for that what I is I will first import the OS model. So no OS. Then I need to know where my file currently is. So for that I will be using this prompt dir equal to OS dot r dot the name, and I'll pass with dot r dot xp bar of my file. Okay. Now I'll load it. So def get planner agent and with open way dot par dot join, and here I'll pass from dir comma my file name. So my file name is planner agent dot md as file. I have to return file dot v. So basically what we are doing here, we are first importing OS module. Then we are trying to find where my this currently file, where my this file is. This prompt reader file. So this file is inside AI developer assistant slash prompts. So this code will give you the same thing. Now I'm just adding from dir, which means AI developer assistant slash prompts, then slash plan agent.m. So I'm just giving full file path. You can also write the full file path you can, by removing this if not, but here I'm just trying to generate it then. So I'm just going to import this function in my planner agent. So prompts dot prompt reader import get planner agent. So now I'm going to load the .env. Going to load the environment variables. Then I'm going to create a dictionary of MCP server that I have. So for that, I have three servers. So file system server I have. Okay. So you can just load it like this: file system server dot MCP. Basically, if you go to file system server, we have created an MCP object. So I'm putting this side here in my player is it. Same for cell servers. Cell is equal to cell server dot MCP, and for git server, so git server dot MCP. Perfect. Now that I have the MCP loaded, I can get all the tools inside this MCP server using a dot get list, uh, a list tools function. Okay, so we'll be using it. But before that, what I want is suppose I say to the LLM that I want to create a snake. Now, since it's an LLM, you will know that it will return you the data in a text form. But I don't want text. I want an structured out. That I want that this is the step one, this is step two, this is step three, so that I can tell the agent that you have to run these steps one by one. So what I need is I'm just going to create a fidentic model for this. I'm just going to create my first model, which is plan step, and inside this we have four parameters. So step number. Now it will be in diesel. Then a tool. So first, basically, step number is the step, which step it is. Then tool, which tool you have to use to do this, run this step. Then you have to give a description about what this step actually is, and then finally arguments to run this tool. Okay, so dict any str. So you have to. Perfect. Now this is step. I will create one more model, which is my execution plan, which is my main plan model. Again, it will inherit from base model. Okay, and then it has two things. First, the goal. What is the goal? And then the steps to achieve this goal. So this step is basically a list of this planning steps. So I just pass it as plan step. So basically, I'll pass this execution plan, uh, what you can say, pedantic model to the LLM, and I will say that always answer me in this format. On I don't want the text output, but a step by step execution plan. So that's what I'm doing here. Now the next thing that I'm going to do is I'm going to create the agent. So a sync dep get planner agent. Okay. Now to build this, first of all, what we need, I want to know how many tools I have, right? because file system has some n numbers of cell has n number of row, Git has n number of. So agents should be aware of that we have the access to these tools. You can create these steps using these tools. So for that, first of all, what we need to do, we need to find out how many tools I get. If for that, I will create another function, a string def build tool catalog. Okay. Now this will return a list of string, sorry, a string. Then I'm going to create an empty list. What I'm going to do is I'm going to iterate on this dictionary. So you can do it like this for living from a server in MCP server dot items. Basically, we are just going to iterate on this dictionary. So label is this file system, server is this server associated with this. Okay. Now since we got the label and server, I need to find out how many tools I have. So for the first server, I can get it like this server dot list tools. Now this list tools basically is available on this .mcp. Okay, since we have created our MCP via past MCP, we can use the list tools to list all the tools that I have inside file server. These are all the tools. Okay. So let's come back. Now that I have access to tools, uh, I have to create a basically a string. So I'm going to do it like this label tools. Okay. So basically it means that label is file system. So it will write file system tools. After that, I will just state on tools, all tool in tools, all the tools that I have received, I have to add it to a list. So first of all, let's find out what is the description of the tool. So you can get it like this tool dot description. Again, this is a feature of past MCP. Okay, so you can get the description of tool via tool dot description dot strip dot split and then pick the results. Okay. Then I need to find out what arguments that the tool takes. So for that, I'm just going to create another function for now, but I can get it like this: tool parameters. Okay. So if you want to get the description of tool, use tool dot description. If you want to get the what parameters that is take, you can take tools parameter. Then I'm just going to append it to my lines list. So lines dot append, and I'm just going to append the tool dot name and then the arguments it takes. Okay. And then I need to append the description. Perfect. Now what I need to do is I'm just going to append this tool description in my sections. So sections dot append slash n dot join lines. Finally, I'm just going to return the entire sections join to it. Okay. So slash n dot join sections. So basically it will create a catalog of all the tools that we have. Here, this tool dot parameters will give a lot of information. You have to again convert into a string. So for that, what I have already created a function. If you go here, so AI developer assistant, agent, manner agent, and here you will find format tags. So I'm just going to copy this thing and paste it here. Oops. So I'm just going to paste it here. Now what this does, this only formats the tools list in another string. Okay, because we can't send list to directly to the LLM, it would get confused. Better we convert it to string. LLMs work better with the strings. Perfect. Now that we have this list of all the tools, I can just get it like this tools text is equal to await build tool catalog. Now the next thing is I want to set the parser. Now I want a pydantic parser. Basically, I have created a pydantic model and I want my LLM to always answer in this format. For that, what I have to do, I have to use pydantic out parser and I have to pass my pydantic object. So pydantic object will be equal to our execution name.
this thing. Okay. So I have created a dedicated parser for it. Now I have to create the prompt. So prompt equals chat from template dot from messages, and we have to pass list. Inside this, we have to pass the system prompt, and system prompt will consist of first of all this entire uh, prompt. This is the prompt for my agent. Uh, you are a planner eight. Okay, it should be .md file, not py. MD and yes, MD package. Now this is a markdown. So first of all, we'll load this entire prompt. But here you will see a dynamic variable tools. Okay, so we need to fill list tools. So what I'm going to do, you have to pass this system prompt. Okay, so system prompt will be this get planner. Sorry, what is the function? Get planner agent. Actually, let's just change it to get planner agent prompt. Okay, so if I just come back to here and I'll update it. Now I'll just change it. Call this function here. Let's just call this function. Remove this thing. Remove this thing and call it here. Okay. So now that we have called it, what I can do is I can append more instruction to my LLM, which will be like this: /n/n, and I can give format instructions. Now, remember we have to pass two values till now. That one is this tools, and the second is format instructions. So basically, our format instruction is simply this thing. I want that LLM to always answer in this format. Okay, so we'll just pass it in a moment. Don't worry. Then I need to send the user message. So user message, and here I will be passing request. Now see two things I know already. The tools that I have, I already know that this is a tools, and the format instruction that is this thing. So two things I already know, but this request I don't know because this is user generated. User can ask anything. So what I need to do is I'm going to pass two things. So partial. This is a LangChain feature which lets you fill variables while generating the prompt. So partial, and here you have to pass tools, and here I'm going to pass tools text. Now this tools you get substituted in this prompt, and I need to pass format instructions. So format instructions is equal to, and I have to pass parser dot get format instructions. Now this is a function which is available in this parser. Okay, perfect. Now these two values are filled. The tools is filled and this is filled. This request we will take from user. Okay, so we'll do the same thing. Now let's create our LLM to chat Google Generative AI. We need to tell the model. So model equals Gemini 3.1 to review. Okay, and we need to set the Google API. So the API key is stored in my environment variables. So I will store it from there. Get env, and I will pass it Gemini API key. Now that we have LLM loaded, now that we have the LLM, we are going to create a chain. So return prompt, LLM, and parser. So basically what will happen? First of all, this prompt will be generated. This prompt will be sent to the LLM, and this LLM will reply in our this pydantic model format. Okay, perfect. Now let's try to run it. So I'm going to create a function, a string def main, and first of all, I'm going to create the planner agent. So planner equals await get planner agent. Okay, then I'm going to create a request variable. Basically, this is my request. So help me create a sleep team. Okay. You can write NP in Python
create a new builder and add readme and instructions. Readme with instructions. Perfect. So I've asked, I want to my LLM or agent to create a snake game and it should create a new cooler and add a readme instructions. Now this will just create a plan. This will not actually execute it. Okay. So let's call the planner agent. So planner is plan equals await planner dot a invoke. Now this is async. Okay. Now we have to send the request. So request is equal to request. Now this request will get substituted here. Okay, so we substituted tools and format instruction from here, but request is user generated. And finally, let's just print the plan. So print plan dot model dump JSON, and I'm going to pass indent is equal to 2. Perfect. Now all that I have to do is call this. So if name is equal to main, in that case, what I have to do, I put for as io dot run and pass the main function. So our planner agent is ready. All that I have to do is we have to run. So let's try to run it. All that I have to do is python m agent dot planner. Let's check it works. So I have a error. So python tick spelling mistake. Let's try once again. Now I have this n is not defined. So let's fix it. Actually, we have to import it from typing. Now where new error origin object is not iterable. It was not awaited. So it says that before list tools you have to add an await. So where is list tools here? So await. But now we try to run it once again. This time to go. We have a new paragraph in the OS as no yep, get in many spelling mistakes. Now I am getting a new error. Error Gemini frequency pro will not found. Again, it's a spelling mistake. Model name is incorrect. It should be a Python here. Okay, so we are moving in the final one step at a time. But this time I should be getting a plan, proper plan to execute it. Let's see if it works or not. So I got some output. Let's see what is it here. See, I'm getting a step by step. So first is goal, create a new folder containing Python snake game. Now we told this that I want a goal execution plan. Then I will get the steps, which is a list. So list of plan step. Plan step is this thing. Okay. It has step number 2 list option are. So step number 1 is create directory and create a new directory named snake game to hold the project file. And it is which tool we have to use create directory. Now this is a create directory tool is inside workspace is interface. So if I go to file system server, I should have a create directory function. So dot file info create directory. So this is a tool name. Okay. So we have to use this tool name and we have to pass the parameter is snake. Okay. Then we have to create a new file. Step number 2, create a use the right file to and this is description and this is the path and this is the content. Okay, so we have already discussed in the previous part. Then the third part is we have to create another file which is create a readme file and put this content inside. So you see our planner agent is working perfectly. Now that we have to do is we have to create an executor agent which actually executes this plan. So next time if I say that I want to get this done, it will actually do this instead of just giving you plan. Okay, so I hope this you got this part. Let's move to the executor part. Now that we have the plan ready, we have to execute it. Okay, so there are two ways you can do it. One is a deterministic way, second one is non-deterministic way. Deterministic way is since we already know which tool to use, what argument to pass, we can directly call the tool. Okay, so this is a deterministic way. This time we will be sure that I have to run this tool and this we just have to pass this parameter. That's it, and your task will be done. Second is non-deterministic way. In that case, what you will do, you will just take the entire plan and give it to the workspace agent. Now, since workspace agent has the access to all of these tools, it will run on your behalf. Now, you have to choose one. I'm going to choose deterministic one because if I pass it to workspace agent, then again an entire LLM will think which step to execute, how to execute, when to execute, like all these things. Okay. So basically I will have to waste more token credits. But since I already have wasted my tokens on planning this entire step by step, I can just directly call them. Okay. Call these functions. So that's why I'm not going to use an executor LangChain agent, but instead I will create a what you can say more deterministic solutions. Executor agent.py. Though it has a agent in it, but it will not be an actual LangChain agent. Okay, it will be simply a function whose task it to run these tools. So for this, I'm going to use this from parathlib go to path. Then from you don't have to worry. Actually, we will create more agents. Okay, for example, we will create an orchestrator, we will create a review agent, we will create a docs agent. So don't worry. We'll learn a lot of things. So from LangChain MCP adapters dot client import multi-server MCP client. Okay. Basically, what we are going to do, we are just directly going to call the entire MCP functions. That's it. Now, from the planner engine, from agent dot planner agent import get planner agent. Okay. From agent dot workspace agent import. From this, I need to import MCP config. Basically, this thing. Though we have an entire agent, I'm not going to call the agent. Instead, I'm just going to get the MCP config. Because why? Once again, since we have already generated entire plan step by step, all the type to is all the tools, and my plan will be executed automatically. You can also do this, like you can import the workspace agent, this get workspace agent, create an object of it, and pass the entire plan to it, and it could be implemented. It could implement it, okay? But we are going for a more deterministic way. So basically, this is going to take an execution plan. So execution plan. Now I'll import it from this pin. This is a parentic based model. Just that's it. And it will return a list of the thing that it has done or executed. Okay. First of all, I'm going to create a client or MCP server client. So my server MCP client, and I have to pass the MCP config inside it. Okay. Then I need to get a list of all the tools. So client dot get tools or sorry, get tools or lead list tool. You can on what. Okay. Then I'm going to create a map of all the tools that we have. So you can get it like this. T dot name. Basically, this will create a dictionary with a key and a pair, a key and a value. So T dot name for key in tools. What we are going to do? First of all, we are going to find all the tools that we have inside this MCP server client. Okay. You can get it via get tools. Here we were getting via this tools because we were very top gone where we were like fetching the tools individually for each MCP server. Here we have a combined MCP server, so for that we have a separate function get tools. Okay, so called client we have get tools. For individual tools, you can get list tools. So what we are going to do, we are just going to iterate on the tools. Now it will give me a T variable. Now T has a name and the tool itself. So we are just going to load it like now. Now I'm going to create a variable list the results. Then I'm going to iterate on my step plans. What step in plan dot steps. Okay. Now I'm just going to print few things. So print f formatted string, and inside it I'm going to print first the step number. So step dot step number. What is this? Basically we are iterating on our plan. So okay, we have got this plan. Okay. Steps inside it, I'm going to iterate it. You can see this is the list, so I can apply a follow bit. Now I can get the step number via dot step number. Perfect. Now the next thing that I have to use, I have to print what tool I have to use. So for that, I'm going to print step dot tool, and then I can also print via step dot description. Okay, like this. So this is just for formatting so that I can know what steps I am in. Now I want to get a tool, which tool to use. So tool map. We already have a map of all the tools that we have available. From that, I am going to use the tool that the LLM has recommended to use. Now I know which tool to use, and it is stored into variable. So you can check if tool is none, if the LLM hallucinated. In that case, what I have to do, I can simply print that this tool is unknown. Okay, I don't know this. So you can just print unknown tool. Okay. Uh, and in say step for two, it means this tool that the LLM suggested is not available. However, we are just going to append it to the results. Okay. And step. Now this is a dictionary which I am appending. Step dot step number error is equal to unknown date. So I'm just going to appending a dictionary in my results list. For each step, I want to append some value it for it. Like if the tool succeeded, if I got any error, if I got any message, something like that. So if my tool call failed, I can simply break the loop. Since my step failed, I don't have to work further. However, if I got the tool, then I can call the tools out tick tools await tool dot a invo and step dot arguments. Okay. Now if I go to here, you will say I have a arguments dictionary which the LLM is suggesting that you have to pass this to the tool in order to run. So I'm just going to pass it. Perfect. Now I can print it and I can simply print the output of the tool, and I will simply append this in my results list, and instead of error I will get the output. I have to append the output. This output output except I got an error in the tool. Okay, so except exception as E spelling mistake. Except exception as E, I can print the error. Okay, and I can append it in my tools results list. Again, this is the error. Okay, so what I have to do, I have to append it to my list. Mixler to convert into string since E is an object, and then again I can break. If my tool call fail, then I can still again break the loop. Okay? If tool call succeed, then I can keep iterating. Finally, I have to return the results. Perfect. Now I have the execution plan ready. All that we have to do is I can call it now. Def main. Okay. We have to make it async so the function is sent. So first of all, let's create the planner agent. So, wait, get planner agent. Okay. And we can actually call fast. Okay. So we have received the plan. Okay. Now what I can do, I can return all the execute plan function. So we have an execute plan. Remember, it is a string function to have to pass away, and you will just have to give it a plan. So this plan, okay, remember this. Perfect. Now we will return the result from this execution function. So let's just call it now. If name is equal to main, in that case, what I have to do, print pushing IO dot run and make. Perfect. So again, what we did, we first created a plan via planner agent. This is my request that I want the LLM to do. Create a new folder and add redo instructions. And you can also maybe add requirements.
But LHT file. Perfect. So,
Okay. Now we can try to run it. So all the type we will run is Python hyphen m agent dot executor agent. Now this is normally a simple function. I can run it like this. So I have a spelling mistake. Execution plan. What are the mistake? Mm, execution plan. Execution plan. Okay, so actually, my spelling mistake is inside main file, but I'm not going to cheat. Let us change it. Execution. Where it used the perfect. Okay, let's try once again. Okay, so the MCP servers are loaded. Starting MCP server. Starting file system server. Okay, so now what we did, we got. Can you give me a definition function? Oops, okay, wait. Actually, we have few issues. So if I go to execute the agent, it is taking an S. We don't want it. If I go to workspace agent, I can simply remove this. Okay, perfect. For plan and agent as well, I can remove it. And if I come from over to here, I can just try to run it once again. Just wait. So I'm getting another error, which is coroutine multiple server. Here it is. In case, basically, whenever you want to create the client, you have to use await. Not here. We have to call it here await. Just try to run it once again. So I got an other error. Result is not defined. But before that, you will see uh, we have a spelling mistake in line 24. So bot a in when we have results list. So we have to open it to results and results. Yep. So let's run it once again. So it is doing something. See here. Create directory, create a directory. So we got the plan, then it's in create directory, create a new directory named snake. So if I see here, you see our agent has created a snake okay, folder. Inside this, we have another step. We write file here the requirement.txt file. So you see requirement.txt file was created. It is asking for pygame. Then the third step is starting MCP's this create a readme file. So if you see a readme file was created as well here. Okay, we call the description. Then the next thing is create a new file snake.py with game logic. So snake it also created a snake file. Now I have to check if it is working on. So since I'm on the Linux, I'm just going to download this entire folder on my Windows system. Okay, so let's just go to my English downloads. First the file is running directly. If pygame is installed, it will run. Since it's not installed, app installed first. So let's run pip install pyman.txt. Could not find version. Why? Okay, so my fault. We install Python R. Okay. So it is installing Pygame. Perfect. Now let's try to run Python snip.py. Okay, so it had created a window like this. Now I'm able to play this game. Okay, you can see it has created a very simple SNIG with requirement.txt and readme.md. Okay, so it's working. Let's see if it works on when I get out. Okay, so press C to control, Q to put. Okay, so it's working. So our agent is working perfectly. We have the execution agent ready. Now the next task that we have is this is one thing. Okay, since we have created a planner agent, we have created an executor function which is executing. What I want is I want to create a orchestrator. Now, what is an orchestrator? It will be your main agent. Okay, I will ask the orchestrator that I want to build this game. So what it will first, it will use the planner agent to plan the entire game. Then it will use the executor to execute the game. In later on, I can also add more agents to it, sub agents to it. Our executor, so our orchestrator will become the main agent, and our these agents will become sub agents. So our main agent will use planner to plan the game, executor to execute the game, workspace agent to work with files or something like that, work with Git. Okay. Uh, and we will add more sub agents like review agent, code review agent, okay, PR agent, all those kind of things. So let's see how can we add an orchestrator. So now let's build an orchestrator. Now this will be our main agent. You can also call it master agent. Okay. And it will decide when to use other sub agents. So this will be your master agent. The rest will become sub agents. Let me just import few libraries or modules. So import OS, JSN, asyncio.in, LangChain.co2s. Basically, we are going to create another agent. So that's why I'm putting tools. GenAI to actually create the and move the LLM. From LangChain.agent, import create agent to create the agent. From workspace agent, I'm importing get workspace agent. From planner agent, I'm getting get planner agent execution plan. And from execute agent, I'm importing execute plan as run plan. Finally, I'm going to unload the .n. Okay. Now I'm going to create the function for this. So function def get orchestrator. Now this is the main agent. Okay. So first of all, I'm going to initialize all the other agents that I have. So I have the workspace agent, get workspace agent. I have the planner agents. So I'm going to await the planner agent, get planner agent. Okay. If you have more agents like review agent, you can just call it here. Then I will need to create another tool. Okay. So now, since this is a master agent, this workspace will become a sub agent. So how can we invoke it? Actually, we can just make it a tool. Okay. So I'm just going to create a tool called plan task. It is going to take a request, which is basically a string. Now it is going to return a plan. Okay. So generate a step by step execution plan or a development request. Returns the plan as this. So this is the docstring of our tool. Okay. So first of all, what I'm going to do, I'm going to call the planner agents. So plan equals planner dot a invoke. Remember, our planner agent takes a request here. So we have to pass that request to the orchestrator here as well. Okay. Now what I'm going to do, I'm just going to try to get the full plan out of it. So full plan equals plan dot model dump JSON. You remember we'll get a identic model from it. So I'm just going to convert into a JSON indent equals to, and then finally I'm going to return the full plan. Instead of returning str, we can say that we are going to return dictionary. Okay, perfect. So this is my first uh, JSON tool. Okay, here I can do add a few statements like creating user plan. Then I can print the full plan. Oops. Okay, so I can print the full plan. I can also print here like print plan created. You can add some debug statements to see actually what's perfect. So this is my first tool. Now what I did actually here is I have a planner agent. So what I'm doing, I'm just putting this planner agent as it to this main agent. Okay, get orchestrator or orchestrator agent. Now I have added another tool. So sync depth execute plan. This is another tool. Okay. Now it is going to take a plan which is a JSON. But I can do it right. Instead of returning dictionary, we can return this. Okay, so this thing model dump JSON basically returns I think probably a string. Okay. This will also return in string. So I can write the instruction for this. Run a plan JSON produced plan task and deterministically. I'm not sure about the ministical spelling. It may be wrong. Doesn't matter. By calling the MCP tools in order returns first step results as JSON. Correct. Now all that I have to do is I have to call the uh, tools. So first of all, I will write a message executing plan. Then I'm going to just run it. So first of all, what I'm going to do, I'm going to convert our string which was returned here into JSON. So execution plan what model validate JSON. So since I have a string, first step I'll check if it is proper model or not. So I have to pass the plan to it. Okay. So basically it will just check if the plan that we receive from the LLM is proper identical model or not. If yes, then I'm going to call my run plan function, which is actually this one execute plan from executor agent, and I have to just pass the plan to it. Okay. Finally, I can return JSON.dumps results and default district. Perfect. So I created another two. So I created two tools. Plan task, which will use the planner agent to create a plan. Execute plan, which will use the executor agent to actually execute the plan. Now I can create another tool. So it will be a sync def workspace, and it will take a query string and will take str, sorry, return the str. Now I'm going to write the string. So delegate a file system cell or get task the workspace agent using a natural language instruction use this when a step needs judgment or to recover from a failed deterministic step. So this is my what we say document for this particular pump tool. Then I'm simply going to return a result equals await workspace is it dot a invoke, and it takes messages. Okay, and you have to return a list since it's a user. It will take a user and then pair. Okay, so this one was a chain. This planner agent was a chain. Here you can say this is a chain. So that's why we passed the input like this. Okay, request request. This is a proper agent workspace. So here you have to pass it in this form. Okay, so don't get confused. Finally, what I'm going to do, return result messages -1 dot text. Perfect. Now all I have to do is I have to create the LL. So I can copy it from here, paste in my here. Now you would see I'm invoking the LLM in each file. You can just invoke it once and pass to every other point. Okay, to PFU. Finally, actually it should be outside, not inside. I'm going to return the create agent. Now it takes the model as LLM. It takes the tools. So we have 3 tools for this agent. Okay. Plan task, execute, plan, and workspace. Okay, remember 3 tools. Then I need to buy the system prompt. So I'm going to print a long system prompt. I'm just going to copy paste. Okay, so you are the orchestrator for a developer assistant. You coordinate especially sub-agent to fulfill the user request. Default version for any development task, create a call plan task with the user request to produce structured plan. Run the plan with execute plan or file determinate execution. If a step in execution reports an error, call back to workspace with a natural language instruction describing what the step was trying to do. For a simple concept task, show me get status, you may skip planning and call workspace directly. Okay, always summarize the final result for the user. Do not just dump the tool output. Perfect. Now all that I have to do is all this all the workspace this orchestrator. So I'm just going to call it isn't is equal to await get orchestrated. Now I need to call it so await or isn't dot a invo. Now again remember this is a isn't, so you have to pass the input in a list form. Okay, so what we have to do, we have to pass messages. Messages, and then you have to pass the user message. So you can pass like this user message, and here you have to pass your name, whatever you want to. For example, what we wanted here, help me create a snippet. You can, so let's just pass it same thing here. Perfect. Now I can simply return or print whatever. So let us print result messages -1 dot text. Finally, let's call if name is equal to main. I'm just going to call a sync IO that run main. Perfect. Now our orchestrator is ready. Again, what we did so far. First of all, we created 3 agents: executor agent, planner agent, workspace agent. Now I'm creating a master agent. And for this master agent, every other agent will become a sub agent. Okay. So sub agent, to create a sub agent, you just make it a tool for this master agent. So we created 3 tools, each for each agent. Then we created the LLM. Then finally we are creating the agent. We pass the LLM to the agent. We pass the tools. We have passed the system. We have already learned all this in previous tutorials, right? Finally, I'm just invoking the this what we call orchestrator. So I'm just going to call it Python -m agent dot orchestrator. Okay, let's hit run. And if you don't get any error, we should be able to execute or get out. So it has started the MCP server. We have an error. So coroutine object plan.has no to do model done this. It's because we have used an await. Anywhere else, here it is already await. But let's try to run it once again. So dating user plan, it goes perfectly. We should be getting the user plan. Then it will be executed. So I've got the user plan printed on the screen. You can see create a new folder containing a computer playable this name. Then it has given me steps. Now it should be executing it. I've got an error. Execute plan model dot validation cannot access local variable plan. Actually, it's plan JSON. You can describe and see. So back to step. I've got a plan from the LLM or from the my planner agent. Now it will either decide to use the executor agent or workspace agent. So it is executing plan from the using the executor agent. Okay, so it is created a directory, it has created a file, it has created another file. Okay. And then uh, and then what was the post step? Created a readme file. Perfect. Now I have successfully created a snake game. It is also giving me a what is done, like Claude Code. Perfect. So to run this, you have to do this thing, cd snake game, keep install icon r requirement txt. Again, you will see a snake game folder was created when pygame. So again, we are getting the same output, but this time we are using an orchestrator. Orchestrator decide which tool to use, which when. Okay, perfect. Now we can add more agents like review agent, docs agent, whatever agent you want. Let's see it as a whole. Okay, guys. Before moving to the adding more sub agents, there's one more important thing that we want to add to our project. So let me just read this thing. So there are a few things that I want to tell you that currently we have an orchestrator which tries to orchestrate whatever the user says. It tries to first plan it, then execute it. But there is a problem. It may be possible that the code written by the LLM is not correct. Code may fail. In that case, how will we ask the LLM to retry? So we have to implement some kind of retry mechanism. So for this, what you have to do, we have to create a new agent called reflection agent, which basically what it will do, it will first try to figure out which steps of this plan failed. If all succeed, then there's no the best case. But if some step fail, the LLM will retry to code that or retry to generate that step. So we have to do the same thing. But for that, first of all, we have to find out which of the steps which of the steps failed. So we have to add two things for that. So I'm going to my execution agent and I'm going to add two parentic models. So step result and execution state. So this will be two things that I am adding. Okay. And I have to import with these. So from typing import list x any and option. So basically I'm importing these four things from this library and then I'm putting from identic base model. Perfect. Now I've created two identic models, step result which will so what is the step of the current, what is the relate to the current step which was executed by the execute. So it will contain step number, the tool used, the arguments passed to the tool, whether it was success or not, if there was some output or if there was some error. Then I have the main pedantic model, which is execution step, which takes the goal, the current step, the number of completed steps, the steps which are failed, and the result for each step. Finally, the status, it is running or it is completed. Okay. Now, what I'm do, we just have to add it to our this executor agent. Currently, our agent simply return a normal result list. But what we get to, we can make it more better by adding it to pedantic mode. That way, I will be able to tell exactly which state wave. For that, I'm going to create a state here, execution state. Okay, and I'm going to start with my setting my uh, code. So it is in plan.code. Okay, then I'm going to set the total is equal to len of plan.steps. So I can find out how many steps I have. Then I'm going to iterate here. Then I'm going to add set the current step. So state dot current step is equal to step dot step number. Perfect. Then I'm going to just print it like this. Then we are going to add the tool. If tool is none, in that case, this is a fail step. So in that case, I have to set the result like this. Step results dot append, and I'm going to add a step result. Step number. First of all, we need to pass the step number here. So it is equal to step number. Then we need to pass it to equals step dot tool. Then I need to pass the arguments. So it's equal to step dot arguments. Okay. What else we need? Success. Since this is a failure case, you will just pass false here. Then we need to pass the error. So error is equal to we can simply pass this. Error is equal to this. Perfect. So we have passed added to my step result. Okay. Then finally, what I need to do, I'm going to append it to my state fail steps. So state dot fail steps dot append step dot step number and state dot status is equal to fail. Perfect. So instead of breaking, this time we put return the state. Also, we no longer need append it to the results because we are adding a tool properly into my state. So this is just a better way. Again, what we have to do, we have to just copy this thing, and if the output is there, then we have to append it as well. So step dot append step number, and success is this time, since we are getting an output, it's a true. Error will be not there. Instead of, you will have a output. Output equals output. Perfect. And state dot completed steps, we have to, instead of, since this is a success step, we are just going to append it into my completed steps. And status will be this time we have to set the status as in past, or you can say completed or running, whatever you want. Okay. If you want to print the output, you can print it. Again, we just have to copy it, and instead we can just simply copy this one and paste it here. Okay, where I don't want the results. So what I'm going to do, actually we can remove this thing. We don't need to check the status. Here this will be fail, everything fail. This time we will have a E. Okay. So we will append it to the fails one. Instead of print, we will simply return the state. Perfect. Now once status. Here it will also be status. Okay. Now, when it is completely done, so we are just going to set the status as completed, and instead of returning the years, we are just going to return the state. Perfect. Now, this time, we will get a uh, like state. So we will just call this thing here, and we will return the state. So after that, we can just simply print the state. So see, we can see what is the final state when the task is completed. Finally, I'm just going to my execute. Uh, sorry, orchestrator. We are going to import few more things. First, the execution state and step result. Okay. So finally, what we are going to do in the execute plan, we are getting the plan here, and then instead of we are results, we are getting state, right? So state is equal to await or run plan, and then we can simply return state dot model dump JSON. Now that we have the complete step by step state of each step executed properly or not, what we can do, right? First of all, let's just print a message here. So we can just print the each step result. Okay, so we are printing status is status dot status. If done is then what is the number of steps completed, and if failed, what were the steps failed. Okay, now as we have very detailed step state, what we can do, we can create another agent, which is a reflection agent. Reflection agent will read this state. If any of the steps in this state is failed, then reflection agent will retry to the execute or replan it. Okay. Now for that, we need to create another agent. So go to the repo, and we have to go to prompts, go to reflection agent, copy its prompt, and I'm just going to paste it inside my uh, file text or reflection agent dot mb. Okay, so it has some description and detailed prompt what is agent will do. We have to create another function to read this prompt. Get reflection agent prompt. Reflection. And here you can see that I will read a reflexive. Reflect and reflect. Okay. So we are just going to import it uh, in let's just create a new file which will be reflection agent. Okay, so reflection agent dot py. Now into the ability. So py what take is import OS from typing input all these things from patent export base all from dot in this. And again, since we are just going to make another agent here, so that's why we put in this libraries. Now, first of all, I need to create few things. So what you do, you can just go to the project here and go to agent and go to reflection agent. We just need to copy few things. Actually, I don't want to extend this video a lot, so that's why I'm just copy pasting things. But it looks like this. We are creating few base models. Okay, so this is a literal. Basically, our failure class can be one of these things. Your failure can either be transient, recoverable, invalid plan. It is an environment issue or it is a fatal issue. Okay? Then, based on it, we can have some kind of actions. Next action like proceed, either retry or recover, then retry, then reply or forward. And we have created two base models like this. Finally, we are going to create our agent. So, first thing, depth get detection agent, detection agent, and first of all, I'm just going to create a parser. So, parser equals pydantic output parser. We already created it back. So, we have to pass a pydantic object to. So, pydantic object is equal to uh, reflection result. Okay. Then I'm going to create a prompt. So prompt is equal to chat from template dot from messages. Okay. And then we have to pass system and user prompt. So my system prompt will be equal to system prompt will, uh we have created this prompt reader, so we have to import this thing in my reflection agent. So okay, we have already put it, spaced it here. Okay, then you can add a permit instruction, so like we did earlier. It's slash and slash n, and you call the format instruction. Okay, so this is my uh system message. Then I have to add a user message. Okay, so I can, so to just add the user message. So my user message will be a mix of two things: step, tool, arguments, output, and error. Now this will be generated dynamically. Okay, so I'm not going to pass these values here. Instead, I have one more. I have a thing like this format instruction. I know beforehand, so I can pass it. Format instructions is equal to parser dot get format instructions. Perfect. Now I have only passed format instruction, which is actually this thing. Okay. So I'm just telling the model that I want the output in this form. Then I just need to create the LLM, so I can just copy it from another one. Now at this point, this is just getting duplicated. But actually, what you can do, right? Or code Gemini is not good. So in that case, if you want that your planner is should be from Anthropic, you can use Anthropic to create this LLM. Okay, so you can just create different LLMs for different tools. So far, we are only using Gemini. So finally, I'm just going to return. Now, this is a chain. So return prompt, LLM, and finally parser. Okay. Our reflection agent is done. Now, all that I have to go to is orchestrator agent. So I have to import it. So from agent dot reflection agent, import get reflection agent. Perfect. Now we have to create a agent here. So reflector is equal to await at reflection agent. Now all that you have to do is you have to create a tool for this particular thing. So you can create a tool, create tool, string depth reflect. Now the thing about this is that it will not run by hand beforehand. Okay, it will not always run. So basically, this will always only run when you will receive a failure, just like Claude Code. So Claude Code just retries to do the fail steps. Similarly, we are also adding an agent which will do the same. So it will take a result step and then step description. Okay, and it will return a string. Now we just have to write the doc string for this. We'll just write the doc string. So judge a single steps outcome and decide what to do next. Uh, s- s- Step result JSON plus the original step description returns a friction result JS with next action. So next action order or next action. So if I go to here, my next actions are also with this things. Next action. I'm just telling the LLM that either reply me with one of these things. Okay. Either this or a failure class. Failure class. Now failure class consists of these possible values. So we'll just come to orchestrator stating. So the better the doctrine, the better the agent will be able to understand your context. Okay. Finally, now we just have to write the logic. This. Now what I'm going to do is first of all add a print statement. Print statement will say like respecting on step. Then what we will do? We can simply get the step result dot model validate JSON. Model validate JSON and pass it the step result JSON. Step result JSON. Perfect. So basically we are taking a string and we are converting it to a pydantic model into step result. I'm going to step result or not. Okay, so we have the step result. Finally, what I have to do, I have to just send this step to my agent. So an agent will reply with a verdict. I'm just going to create a call the agent. So reflector dot a invoke. Now remember, this is a chain. So we have to pass values like this, not the messages with step number equals step dot step number. Then we have to pass the description, tools, argument used, output, and the error. Okay. Finally, I can print the verdict. So verdict dot next action. So here it will be abstract, it will be dot next action, and we can also print verdict dot failure class. Failure class. Since our agent is supposed to return this, so if I go to reflection agent, it will either return with failure class or with the next action. Perfect. So our orchestrator is here. We have added it. Now we can finally return verdict dot model dump this. And the last thing that I have to do is I have to update the this get orchestrator main orchestrator prompt. So you can just go to this code on orchestrator.py and paste the this thing for a more detailed prompt. Okay. So what you do, call plan task, run the execution plan, its status field. Then in that case, mine the matching step in the required plan to required description called reflect with the steps into. So if there is a failure, then in that case we have to call the reflected. Remember, this will only work when you have failure. If there's no failure, then you can say that there's no failure. Uh, okay. So yes, this is it. Now we can just call or run this project once again and see what is the output. So Python, let's this time let's try to build something else. Tell me uh, next. help me create a fast API application with simple CRUD operations or actions. It should use SQLite as database. Okay. Okay. So now let us try to run it and see if it's working or not. Python name using .orchestrator spelling ORCH EST RTOR. Let's try to hit enter. I have an error. Bit application isn't found. Uh, set completed. We have bit application isn't found. Set application isn't. Yeah. Let's fix it. Let's try to run it once again. So now it's going to create a user plan. So we have got some plan with 3 steps. So let's see if it works or not. So it has written a file, it has written another file, then it has implemented third step. Here is a summary of files created. If I'm not TXT, so if I go where it was operated system, so you will see this time I didn't ask it to like create a new folder, so it just made it inside the main. So it said C, you'll get a requirement TXT with 3 things: readme file, okay, and then the main file. So see, it has created an entire fast API application. Perfect. Now let's try this. I'll ask to let's say copy X path, and this time I'll go to my agent, go to my Orchestrator agent, and I'll save. Need file and add block strings and comments to the application. Okay. So I've said that you have to read this file and then add block strings and comments. So let's try to run it once again. Let's see if it works. So this time we had created a new plan, read the current intents of main pipe file, understand logic, write the updated intent back to the bean file, and verify the syntax. So it is doing something. It has run the command verify the syntax of bean file and solve numerous queries. So text success. Okay, so it has brought an error. So that's why I just fix ran. I have got an error. It says here written all coiling functionality got utility blocks to the comments. So it didn't work. So now it will just retry it. See, it has done a retry, and finally it has rewritten the content back. Okay, so I have successfully updated your application. Here is what was done. Read the original file, did something, and save the file. So here is my link code. You can see there are a lot of doc strings and comments added. So perfect, it's working. Right. So here's the it for videos, guys. We are nearing the end of this series.
So it's working. All that we have to add is you can add as many agents as you want, like a docs agent or plan reviewer agent or PR reviewer agent, all kind of things. But we don't want to get this video too long, so we'll try to keep it short and add one or two more queries. That's it.